Another chapter on hypothesis testing is what the seniors are going to miss.
Oh,
Darn.
So this is hypothesis testing.
Why? Hyosis?
Yeah. That's hyosis.
Hypothesis testing for 2 independent samples. We have not done anything with 2 samples before. We've just taken 1 sample from a population and we've done a lot of stuff with it. Now we're taking 2 samples from 2 different populations for 2 independent samples, both over 30. So we're talking large samples, so we're going to be talking z-scores again. So what we're looking at here, what we can test is there a significant difference between our 2 populations? So yes, there's probably going to be a difference, but is that difference significant? That's the key word. So like, we could ask the question, is there a difference in the amount of time teenage females spend online versus teenage males?
Yes. Yeah.
So our 2 different populations are obviously teenage females, teenage males, and we would be taking samples from each and looking at the average amount of time and seeing is the difference, because they're probably not going to come out identical, but is the difference there significant? That's the kind of hypothesis testing we're going to be doing. So, it's the same 5-step process, but our formula is different. So we're going to still, so the 5-step process, by hand process. You're still going to write the ho and the ha and the claim. But you're going to see we're going to these are going to be slightly different because we're going to have the 2 samples in the ho and the ha and the claim. Then we will with your ha, you're still going to make your shaded rejection region. So you're going to make the graph. By the ha. Because these are large samples, you're going to use inv norm of the left area to get your critical z-score. Then here's where the formula changes slightly. The z-score, and what we're testing is the difference in the 2 sample means. We'll have 2 samples and we're testing the difference in them. So it's going to be x bar 1 minus x bar 2. So the x bar 1 minus x bar 2, then we're going to subtract the difference from the whole population 1 minus population 2. Divide by, formula's a little bit ugly, S1 squared over N1 plus S2 squared over N2.
Short.
Yeah?
Does it matter which one you use as 1 or 2?
No, as long as it matches. Like if I did females as 1, I want females here. Kenley?
We still have to do homework over time.
Yes? So if I started with females, I want to start with females here.
Oh,
If you choose males first, then you want males here.
okay.
So you can make whichever population one that you want.
Okay.
Sounds awful.
It's not bad. Okay. Then we're just going to check to see if our z-score lands in the shaded or unshaded. So step 4 is just like always before. You're either going to reject the whole or fail to reject the whole. So you make your decision and then you interpret, you know, neat, true, false. Neat, neat, true, false. So it's writing the claim, the very first line, that's going to be a bit of a challenge. But once you get past that, it's all the same stuff you did in the last chapter.
So it sounds like it sucks.
We're going to find out here in a minute.
Probably sounds a lot easier.
So we really have just 4 examples left.
And then we move on to day 2?
That'll be it. That's everything.
Oh.
I'm kind of streamlining for you,
Oh, well, thank you.
giving you just the necessities. I think you'll be fine. Okay, here we go.
Okay.
That was you.
That is mine.
I'm gonna give you credit for that one.
Okay. So number 1. Let's see, a survey indicates, so this is a survey. That the mean credit card charges for residents of New Hampshire and New York. So survey. Mean credit card charges. And I'm going to make a little table since we've got the 2 samples. I don't want to write it all out in words. So we're talking about a mean. And we've got New Jersey versus New York. And let's see what we've got here. No, it was New Hampshire and New York. Sorry, New Hampshire, New York. That's an H. So $3,900 in New Hampshire. $3,500 in New York. The survey included a sample size of 50 from each. And these sample sizes do not have to be the same. They could have taken 30 from one, 50 from another. As long as they're both over 30, we're good to go. And the standard deviations in New Hampshire, for that data set, it was a $900 standard deviation. And the standard deviation here in New York was $500. Okay, we're going to test this at 1%. Is there enough evidence to conclude that there is a difference? So the claim is that there is a difference.
Wait, does that test, does that go for both of them?
Yeah, this is one test for both data sets, so it was kind of just like a whole new line here. There is a difference in the mean credit card charges.
Is this just like one charge, like,
I'm thinking this is, it doesn't say,
hopefully for like a month or
I'm going to say it's definitely monthly because the bills only come out monthly. I'm going to say monthly. I can't live in either of those towns. Okay, like I said, it's the claim that you have to kind of get used to writing. So, there is a difference. Is it telling me one's bigger than the other one? No. So what we're going to say in the claim, and we are talking means, so that's mu, and I have to distinguish between New Hampshire and New York. So I'm going to say the mean of New Hampshire, with a little NH, and the mean of New York. What symbol can I put in between those two to say that there is a difference, but not distinguish by saying one's bigger than the other one?
Does not equal.
Does not equal. They are not equal. That's what they're telling me when they say they're different. So they are not equal. So the thing is, we do not want to leave our claim this way, though. We want to write the claim so that it shows a difference. I don't know where I kind of put that at. I'm going to talk about, is the difference significant? So what you want to do is write it as 1 minus, oh, it's in the, down here in my formula. We want to write them as 1 minus the other one, the whole in the, or the two means. So what I want to do is, and it doesn't matter which one I subtract from one side, I'm going to say I'm going to subtract the New York from both sides of this. Just going to rewrite it. So on the left-hand side, I'm taking the mean from New Hampshire and subtracting the mean from New York. Still going to have my not equal to. What am I going to have on the right-hand side when I subtract the mean of New York from it? 0. So this is the claim, rewritten as a subtraction. Is this the whole or the ha? This is the ha. So what's the whole going to say? That the mean of New Hampshire minus the mean of New York is equal to 0. There's the whole.
Is it gonna be the 0 every single time?
Not every single, our third one's not going to be a 0. Okay. So we want to get it to be a difference of the two. So now that's the only thing that's different from what we've done before, getting that to a difference. So here we go. Let's go with step 2 is the graph, right? What kind of test, or where's our shaded region going to be at?
Both tails.
Both tails. Two-tailed test. If it was an 0.01%, how much is shaded in each tail?
0.005.
Gosh, you guys are good. Still working strong. I like it.
That's actually the first thing I listened to.
Okay.
Yeah, I was about to say, she's like...
Okay, so now we need to find the z-score.
Girl.
So if we do the inv norm of 0.005, anybody? Try again.
-7.
Wrong.
You're wrong.
You're wrong.
Dude, I don't... You got paper clips? The Loma's princess over there, she's got something stuck underneath her tail. Might have.
Do you want the small paper clip then? Come on. Trying. Not very successfully. Here you go.
Thank you, teacher.
Matt, what'd you get for us?
Plus or minus 2.58.
2.58 negative, 2.58 positive. Okay, so now we're at our formula. So now we want to do the z-score. Now pay attention to the way we wrote, and remember we're testing the whole. I put New Hampshire first minus New York. So when I do my sample, I want to match that. So that's why it's important that you put the labels down here. So the mean of New Hampshire was 3,900.
Okay, question.
Yep.
If we have to, does it matter which one you subtract?
No. It's just that now that I've established that, I want to do the sample the same way. But, so, if I look at the formula, it says take this difference, the 3,900, minus the 3,500. And what's the difference between the two sample means in the whole? We've got it right here. The sample, or the population ones, I mean I said sample, the population ones, the difference is 0.
So 0 minus 0?
Yep. So in my formula, right here, mean 1 population mean 1 minus this is from the whole. I should probably put that here. It's from the whole. And the whole, that's a 0. Most times, it's going to be 0. And then on the bottom, we've got this ugly square root.
So how come the ha is that?
We always test the whole, though. Every time we do a hypothesis test, we're testing the whole to see whether we're going to keep it or reject it. I don't care where the claim is at. It's just the process we go through.
So the 3,900 and those two are the
Samples.
sample means?
Yes.
Okay.
Those are the X bars.
All right, George, I can do the next part.
Okay, so now the formula says take the S1 squared over N1. So that's, if I look to New Hampshire, that's 900 is the S
Squared.
squared over the 50 plus 500 squared over the 50. And then calculator.
That's magical calculator work right there. Casey, I want it.
I don't know if I got the right answer or not.
Let's see, that top's going to be 400. Just going with that. Square root 900 squared divided by 50 plus 500 squared divided by 50. 2.75.
Hey, that's what I got.
No extra parentheses needed. So if the z-score for the sample is 2.75,
Wait, when you say no parentheses,
no extra, oh, I did the 400 here. I just did that in my head, so I didn't use those. I just put 400.
where else did you put it?
None.
None?
Nope.
I thought it was funny, I think it was last week, one of the days I missed, you guys said like, so who's got the answer? Oh, Matt's not here, someone has to get out their calculator.
Yep.
Okay.
Hello.
So what are we doing with our whole? We're going to reject the whole. Now that our poster's gone, what are we saying about the claim?
It's true.
It's true.
Please try it.
That's a 50-50.
Yeah, it was a 50-50. All right, there's one by hand.
It's okay, Amanda. Alyssa. You just called me Amanda almost. I did not. We're halfway through to the bottom.
What was the conclusion of that?
Reject the whole
Cool.
true. Yeah. I don't need it. We're so aggressive today. What is his hair? What does he have like three like alfalfa here? Quick cut. I'll try you. Yay. Okay, got me the water and everything.
Okay, the program for this section.
Shut up.
The program is called a two-samp, because we're working with two samples,
Wait, how do you get to this program?
patients,
It's a virtue.
z-test. Two-samp z-test. So the next example, okay, the AAA, American Automobile Association, claims that the average daily meal and lodging costs while vacationing in Florida,
Claims average
average cost to vacation in Florida is greater than the average cost in Maryland.
I knew it was going to be important.
Really, Kenny? Good for you.
Okay, our sample data to test the claim, I'm going to give it to you in table format again. We've got Florida and Maryland. think it's MD. Okay, the mean cost in Florida, this is daily cost, $252. This is back in 1997.
$252?
A day for lodging and meals.
Oh, a day.
Standard deviation, $22.
That's still really small.
And sample size, 150. Maryland, the average was 244. So yes, you see there's a difference, but is it a significant difference? This is what we're testing. Standard deviation here is 18. Sample size was 200 this time. So definitely large samples are both over the 30. We're going to test this at 5%.
Wait, the S is standard deviation?
Correct.
It's a fat ratio.
Oh. Standard deviation. Standard deviation. Okay. So we still have to write the claims, and then we're going to run the program. So claim. Okay, the key word in here is average. What's another word for average?
Mean.
Mean, so these are the mu's. So we've got the mu for Florida and the mu for Maryland.
Okay, can I just write the mean minus
Yes, you can go right to that if you want. Okay, what are they telling me about these two averages? How does Florida compare to Maryland?
greater than?
It's greater than. Making this the ha. Now we want to write it as a subtraction. Does it matter which one I subtract? No, but I'm going to bring it over to the left, so I'm going to choose to subtract the average of Maryland from both sides. So as a subtraction, it's going to be the average from Florida minus the average from Maryland is greater than 0. So then the whole, which we're going to test, is going to be less than or equal to 0. Okay, now we're ready to run that program, and all we want, same thing as before when we run a program, is the p-value, because we do it by program. This one's by program, so no graphing when we're programming. So we're going to run the program and find the probability. So,
What is, oh, never mind. This really confused me, Schwartz.
okay, figure it out.
Yeah, are we, do you want us to highlight the data or the stats?
I'm already.
We have the stats. Data means it's all in a list somewhere. All right, so stat. And over to test, just like where all the other ones are at. So stat, over to test. And your 2-samp z-test is down at number 3.
So happy I don't have to care about this.
Oh, I might just pick one problem off your homework and give you your 200 points on whether you get it right or wrong tomorrow. Okay.
I think Kenley's gonna do it.
How else am I going to get you to stop from writing garbage down on your paper? Okay, so 0 for you. Okay, here we go. The 1. What am I calling my group 1 here?
Florida.
Florida, because I've written that first. All the Florida information is the stuff with the 1 next to it. So that sigma 1, I don't have sigma, but I have an S. That's a standard deviation. That's the only thing I can use in place of it. So I have to go with the 22 here. The second standard deviation is the 18. X bar 1, I'm back to Florida's mean. N1, 150. Over to X bar 2, 244. N2 is 200. And same thing as before, we want the ha sign. The ha sign is pointing to the right, so I want the symbol that's pointing to the right, which is the farthest one over to the right.
Oh, I did that.
And then calculate.
1.0. It's actually like 0.000.
Yeah, times 10 to the negative fourth. These are probabilities. They're not going to be over 100%.
Okay. No. Oh, yes.
We want the p. And now how does p compare to alpha? Less than alpha. Do you remember what to do? Reject the whole. That would make the claim, this was the claim, true.
Wait, how is Jesus Fish bigger?
Because it's 0.5. This is 0.00014
Oh, okay.
times 10 to the negative fourth.
Oh, now I understand now.
Okay, Schwartz, do you want to tell me the probability rule? Because I don't think I wrote it down from last chapter and I got really confused.
Oh, the p?
Yeah.
If p is smaller than alpha, it's reject. If p is bigger than alpha, you fail to reject. Okay, and then our third one's going to be where the difference is not 0. They tell me what it is.
Would it be p is greater than or equal to alpha?
It's actually the less than or equal to is the one that's reject. Yep, because we have to do one where the difference is not 0. And that can only be done by hand. It cannot be done with a program.
Is it going to be longer than the first one?
Same as this.
Okay. Are we only doing 3?
Same as the first one. Patience, I said 4. Okay. This one is going to be the difference is not 0. So I just kind of want to head that up. Difference is not equal to 0. It must be done by hand. Okay. So then the information you need. Okay, in 1981, a study of 70 children under 3 years old found that the mean length of time, so this is 1981, or excuse me, 1981. They studied 70 children and found the length of time spent in daycare or preschool per week. So the average number of hours in daycare was 11.5 hours of daycare. Standard deviation, 3.8 hours. A recent study, back in 1997, so I might as well stick it in there. Let's see, 65 children. The average time spent in daycare jumped to 20 hours per week. Standard deviation, 6.7 hours. Okay, the claim being made, the claim is that children spend, in a minute, 9 hours
Bless you.
a week more in daycare in 1997 than in 1981. We're going to test this at 1%. If you can get by the claim, These are easy. So what they're telling me, when they tell me that they spend 9 hours more, that means the difference between the two is 9 hours. Are they saying it's more than 9 hours, or are they saying it is 9 hours?
Is 9 hours.
It is 9 hours. So, the claim. So which one's bigger, the 1997 or the 1981?
97.
Because when I subtract, I want a positive 9. So I want to take the mean from 97 and subtract the mean from 81. And what are they telling me in the claim that this difference is?
9.
It equals 9. If it had said that children spend at least 9 hours a week more, what would I put in here instead of the equals? If it said at least 9,
You'd put like a less than or greater than.
greater than or equal to 9.
Yeah.
If it said no more than 9, I'd have a less than or equal to. But they said it's exactly 9. It is 9 hours more. That's why it's an equals. So, it's just interpreting that and coming up with this equation. I think that's the most challenging part of the whole process. The rest of it's just step by step, put one foot in front of the other and get there. So we already have the subtraction, so I'm ready to go. This is the hoe. So the ha will be not equal to 9. And that ha is telling me by hand what kind of test. Where's my shaded? Two-tailed. And we've got the 0.005 again. And if we look back at example 1,
So you M norm.
yep, that would be
Plus or minus 2.58.
2.58. And now we're ready to turn our sample data into a z-score. So when I do my formula, I need to take 97 minus the 81 data. So 1997, the average was 20, minus the 11.5. Oh, 5. I wrote a 9. So do you need me to show you the formula? Are you good?
Yeah.
So
Just
the
right.
formula that I'm plugging into,
Oh, no.
you're good?
Yeah.
Yeah.
So 20 minus 11.5,
I thought you meant like right now.
oh, minus, this is the difference in the two populations. What are they telling me the difference in the populations is from the whole?
9.
A 9 there instead of a 0. And then the bottom's that ugly square root, where I need the standard deviation squared over the sample size. So that's 20 squared over 65.
Are you, wait, standard deviation is
Oh,
6.7 squared.
I grabbed the wrong one. 6.7 squared.
Yeah, you were really freaking me out.
Oh, yeah. Looked at the wrong thing. 6.7 squared. Did I have it in the second spot on the last one? I think that's why I looked there. Okay, and then 3.8 squared over the 70.
Press enter, short.
Hey, so I got
Negative 0.53.
That's 6.7 squared?
Yep.
Fail to reject.
So we are going to fail to reject the hoe.
Isn't it mean?
It is NEEF. Okay, good there?
Yep.
Are we done?
Oh, we have one left. Stay with me.
Oh.
But you said we had 3 exams.
4, I said 4. I did not lie, I said 4. I totally said 4.
You did, but I mean, what else can there?
A confidence interval by program. I'll just throw one of those at you, then we're done.
How much room is this?
Very short. Super short. Confidence interval for mu1 minus mu2,
How much room you said?
about a quarter of what we've had. The program is called 2SAMP Z int. Confidence interval, program ends in int. Okay, very easy to use, totally straightforward. We're not doing these look at what the formula looks like by hand. We're not going to go there. I just want to show you to appreciate a little bit here.
Yeah, I love you.
Yeah, we're so not doing that by hand.
Is that crazy?
That's ugly.
Who even does that?
I don't even know.
Who even came up with that?
I don't know.
I want to do it.
No, not by hand. Okay, a study was conducted to see if an herbal supplement helped to reduce weight. After 12 weeks, so we've got herbal people, this is example 4.
How much fruitcake?
Herbal,
My brother had class for my first time.
42 subjects using the herbal supplement and a high fiber, low calorie diet had a mean weight loss of 3.2 kilograms and a standard deviation of 3.3. So the standard deviation was bigger than the average. So that means some people gained weight here. Okay. During the same time period, 42 subjects using the placebo where am I at? 42 subjects using the placebo and a high fiber, low calorie diet had a mean weight loss of 4.1. Standard deviation 3.9. Construct a 95% confidence interval for mean 1 minus mean 2, where mean 1 is the herbal. So 95% confidence interval for mean herbal minus mean placebo.
Break out the calculator.
There we go. Calculator will do that big, ugly formula for us. Stat, tests, int. We want the 2SAMP Z int. Okay, so we've got our standard deviations first. Herbal is your 1, placebo is your 2. And there it is. So the average difference in weight loss is negative 2.445 to 0.645 kilograms.
I got negative 2.492.
Anybody else match mine?
69179.
You match mine? No, you just typed a little digit wrong. So a negative number, I just want to talk about what a negative number means. If I'm subtracting and I get a negative, that means the second number was higher. So that means the placebo people lost more weight than the herbal supplement people. For the most part, because the confidence interval barely gets into where the herbal people did better than the placebo, because that would mean a positive difference.
So what are the values giving us?
It's a range of the difference between these two weight losses. The average difference,
Okay.
yeah, is somewhere in that range of numbers. Okay, that's it for today.
Oh my god, yeah.
Oh, you made it. Your last section of notes.